Now we're going to move on to the DNT family, and we kind of call the DNT 900 and the DNT 2400 our big DNT family. They're not very big. They're smaller than the width, so it's 1 1/4 by about 2 inches. So very compact size, both in 900 megahertz and 2.4 gigahertz. And these actually have variable data rates. So they're 4 over-the-air data rates from 38.4 kilobits per second, 115.2 kilobits per second, 200 kilobits per second, 500 kilobits per second. And then variable power levels from 1 milliwatt to 1 watt for 900 megahertz, and 1 milliwatt to 100 milliwatts for the 2.4. And the reason we stop at 100 milliwatts for the 2.4 is one of the values of 2.4 is it's available for use worldwide. But if you're using it in Europe, in the European countries, you can only go to 100 milliwatts. So we stop. We stop at that point. I'm getting into kind of some speeds and feeds here. I should tell you that you'll have access to this presentation afterwards, so you'll be able to refer back to some of these numbers if they're important. But what we've done with the DNT family is now we've added analog and digital I/O and a SPI port. So we still have the UART. But we've added the SPI port, which allows it to be embedded with lower cost micros that only have maybe a single UART, and if that needs to be used for something else. And then we have analog and digital I/O, so you can connect this directly to sensors, switches, outputs, things like that, and not have to create a serial language a command language that another coprocessor then will turn into the I/O. You can manipulate the I/O directly either through the local serial port or over the air from other modules. Then we have auto reporting and sleep modes. So you can actually put the radio to sleep, which puts it into a lower power consumption. But then you can also, excuse me, you can also configure it to on either time or interrupt or analog voltage basis to wake up and transmit its data. So now this is a nice feature to have because now you have an application that doesn't have to sit there and go around and poll all of the nodes. The nodes are going to auto-report on whatever situation it's configured to do. So it's a very powerful feature for the radio, particularly with the analog and digital I/O. So now you have the ability to create a wireless sensor node that doesn't require any other intelligence. All the intelligence is in the radio module. We also have encryption, which is the AES 128 encryption, and also authentication. Now what the authentication does is you have the ability to load in the radio itself 16 radio serial numbers, and only those serial numbers will be allowed to join the network. And if you have more than 16 nodes in your network, the radio can be configured to output an authentication request to your application, where you can say, hey, a radio with this serial number has requested to join the network. Should we allow it? And then the application can have a longer range of serial numbers and say yes they can join or no they can't. It also has tree routing. So tree routing is a quasi-mesh. It's the same mesh technology that Zigbee uses, as a matter of fact. It's tree routing where there is a hierarchical basis to the network. You have specific routing nodes and leaf nodes, and then a network base or coordinator. But it does allow you to extend the range, and it does it in a more efficient way than, say, a store and forward routing scheme where you have a certain number of nodes that are simply repeating everything they hear. This is really kind of unicast all the way through the network. There's a second diagnostic port, and this is important because if you have an application where you want to monitor the health of the network, you can do that without that diagnostic information being embedded with the application data. So you just simply have a separate UART where all anything that's coming out of that is the diagnostic data. So you can have a diagnostic utility that only does diagnostics, and then your application only deals with the application data. So a very easy and straightforward way to get real-time network health information without complicating the application. It has over-the-air programmability, so we don't upgrade the firmware very often, but if there's a new feature we bring out that you want to add to units in the field, you're able to do that over the air, so you don't have to send someone out to each node to be able to reprogram it. And the network really is the number of remotes is limited by the amount of data you really want to send, but there's no logical limit to the number of nodes. You can have very large networks. And then the list price is only $69. So if you look at the value proposition here, is just unsurpassed flexibility. It's a frequency hopping radio, and at $69, it's less than half the price of earlier products. It competes, and you'll see this in a minute, with some radios that are selling for $150. So the DNT, the big DNTs, where do you use those? When they want frequency hopping performance. When do you want frequency hopping? That's when you have interference and multipath concerns. When multiple applications are being addressed with the configurability in terms of RF data rate and power, one design can work for a number of applications. And it's been interesting to me, the number of customers that we have, that they really weren't sure how much RF data rate they needed. And so they've been able to look at it and say, well, does it work at 38.4 kilobits? No, that's not enough. Then I'll bump it up to 115 too. But they have the ability to play with that, and they also gives them some future proofing with the higher data rates of 200 kilobits per second and 500 kilobits per second to add more features and functionality. We say the application is moderately cost sensitive. I mean, this is a great value radio, quite honestly. But we have some radios that are even lower, lower price point. So we say moderately cost sensitive. And then obviously if you're having a sensor application, the ability to handle the analog or digital I/O is a real key feature. You can run these on battery. You're not going to get years on a battery with the big DNTs, but you will get months. And then where you need large networks. So those are some of the keys to look for when talking to people about what radio. So why do the DNTs win? And they win because they outperform radios that are much more expensive. And they outperform them in terms of the power, the adjustable data rates, the encryption, and this tree routing. They win because they're available on both 900 megahertz and 2.4. A lot of people think that, believe that 900 megahertz will go farther, and they're right to an extent. But if they want to sell internationally, they need 2.4 gigahertz. So this is one platform, and they can decide what radio to use depending on where they want to sell it. And then the networking features that we have. We have a TDMA, a time division multiple access scheme, where every remote gets the same number of same amount of bandwidth, and that's limited to 16 remotes. Or this carrier sense multiple access. So this is the listen before talk mode, similar to Ethernet, similar to Wi-Fi. And in this mode, there's no limit to the number of remotes. We have heartbeats, where you can configure the radio to send a brief message saying that it's still part of the network. So that if a remote is only transmitting very infrequently, you can know more frequently that it's still there, and it's only not reporting because it hasn't asked to, as opposed to the fact that it's not reporting because it's left the network. We talked about the auto reporting, which is a key feature, really simplifies monitoring and sensing applications. The authentication gives you an additional level of security above the encryption. And then you get join and leave messages. So you have the ability to know when a node joins a network and when one leaves, which is a nice feature to have. Then with all the different things you can configure, the hop time, which is how long it stays on each frequency, the number of retries, because all of the error detection, correction, and retries are built into these radios. The ability to have co-located networks, subbands, we talked about that with the widths, and then the analog and digital I/O, and then that it provides great value to customers while solving a lot of their problems. So the only two radios that really can give the DNT 900 and 2400 a run for the money are the DNT 90 and the DNT 24. So these are what we kind of call our little DNTs. And what you'll see is they're similar, but they're just a reduced feature set. And that reduced feature set lets us remove some costs from the radio and bring it out at a different price point. So the 900 megahertz is 100 kilobit per second over the air data rate. So that's the only data rate there is. It's not adjustable. And we go from 40 milliwatts up to 150 milliwatts. So we're not going to the 1 watt, but for a small low price radio, this is a high output power. And since a lot of people want the 900 for additional range, having this extra power can make a big difference. At the 2.4 version, it's a 250 kilobit per second. So why is it different? Well, there are a couple of reasons. One is that there's more bandwidth at 2.4, so you can have wider channels, get a little bit higher data rate, and still have a good frequency hopping performance. And then the 10 milliwatt to the 100 milliwatt, and the 100 milliwatt, like we said before, is for the international usage. Again, we have analog and digital I/O with UART and SPI-port. Has the auto reporting and sleep modes, and it has the encryption. It has ES-128 encryption. It doesn't have the authentication. All right, so that's one place where we're able to reduce the cost a little bit. These radios have store and forward repeating, so you can extend the network, but it's not as efficient as the free routing that the DNTs have. It does have a second diagnostic port. It has the unlimited number of remotes. It has a unique kind of combination between TDMA and CSMA mode, so there's no limit. And it's available with a chip antenna or the UFL antenna connector, and pinned or surface mount. And then the list price, $29, really setting a new price point for frequency hoppers with this type of performance. So the value proposition here is just everything you get at the price. So it's not strictly a price offering, even though it is a price leader. If you only looked at the price, it's a price leader, but when you start looking at the features and functions, it just blows the competition away. It truly does. So you'd want to look at the DNT, the little DNTs. Again, frequency hopping performance. So you get the robustness and the immunity to interference. The application is very cost sensitive. So list price of $29. You can put a lot of radios and a lot of different products at that price point. You need the analog and digital I/O. You want to have both the 900 megahertz and the 2.4 gigahertz in a drop-in replacement, and you're going to have some fairly large networks as well. The DNT 24 is new, so we've got to get the word out that it's out there, and we're working hard to do that. But we are seeing some good uptake on that in the early days as well. All right, so why do they win? So it's really the lowest cost frequency hopper out there, and you get it in both 2.4 and 900 megahertz. But even at a low price point, you still get some very sophisticated features in this in terms of this TDMA CSMA mode, the heartbeats that we talked about to let you know if it's sleeping. It's sleeping. That's why it's not reporting. So it's in the heartbeat every once in a while. The auto reports, and then the join leave as well. Then we also have some specific sensing functions where we can do averaging. So when we're doing these auto reports, we can report the kind of the instantaneous value, or you can configure it to take a number of readings and only send the average value. And then we have adjustable scaling on the A to Ds that allow you to kind of zoom in at a particular level. So if you're interested in a temperature, let's say, but only when it gets above 50 degrees C, then when it gets above 50 degrees C, you don't care about reading less than 50 degrees C, so you can kind of adjust the scaling so you get more resolution between, I say 50 degrees C and say 70 degrees C. So it's these were driven by some sensing customers that we have for the radios, and it's a very powerful feature. Again, what this does is it removes the need for coprocessors. These radios can be the only intelligence in these end devices. And you still have the same level of configurability with this common footprint. I'll talk about that a little bit more. And again, the bottom line is we're solving problems for our customers at a great and delivering great value. So now if we look at the whole DNT family, because it is sometimes a little bit confusing, we have our big ones, the DNT 900 and the 2400, and you can see the relative size, 1 1/4 by 2, and then our little ones, the DNT 90 and the DNT 24, which are 1 inch by just under 1.5 inches. So you can see the 900 megahertz, the difference in power and the difference in maximum data rates, and same with the DNT 24 and the DNT 2400. So when we talk to people, if we if the DNT 90 or 24 will do what they need, then obviously that's the one we'll lead with due to the better price. But if they don't have if they won't meet the need for whatever reason, we can then take them up to the DNT 900 and 2400, and we still have a very cost-effective radio solution to offer them. So looking at it more from the feature standpoint, I'm not going to go through all of these because you have this as a reference, but this just kind of shows a little, a more reduced feature set, a little more robust feature set. Here, the advantage is we've got different technologies in the same footprint. These, you don't have that, and then the price difference is important as well. So these are the last two slides really help you understand and position for your customers the difference between the big and the little DNT.